This is my project on the body systems in microgravity. I chose the digestive system. The digestive system is a group of organs that stores food and breaks it down. It converts food into energy and nutrients and distributes it throughout the rest of the body. The digestive system consists of many different parts and organs, including the mouth, esophagus, stomach, liver, gallbladder, pancreas, small intestine, and large intestine. Part of the digestive system is the gastrointestinal tract, or the GI tract. The GI tract moves food through the digestive system, helps digest it, and then eliminates the waste. The digestive system is controlled a lot by the nervous system and the autonomic system. Microgravity is the almost negligible gravitational pull felt in space. It is so weak that it makes you feel weightless. All of the systems in the body are affected by microgravity in various ways, especially when exposed to it for long periods of time. It affects some more than others, and sometimes the effects do not return to normal when coming out of microgravity. Microgravity has no huge impact on the digestive system. There is no fresh food brought into space because it would not last, and some of it would float away and be impossible to eat because of the microgravity. This leads to dietary changes for the astronauts, which affects the digestive system. The lack of fresh food limits the amount of nutrients that the body is getting. Microgravity also affects something called the microbiome, which is the bacteria in the gut that helps digest food. There are two main groups of bacteria in the microbiome, called the firmicutes and the bacteroidetes. There is a set ratio of the number of firmicutes and the bacteroidetes normally, but when in microgravity, the ratio shifted. The firmicutes increased and the bacteroidetes decreased. This affects how the food is digested in the astronauts when in microgravity. Upon returning to Earth, however, the normal ratio returned. The digestive system, when affected, messes up the rest of the systems in the body as well. Many of the systems in the body are dependent on the digestive system in various ways, which is why damage or inefficiency of the digestive system can be dangerous. There are some atmospheric and gravitational changes that directly affect the digestive system. There is a change in the amount of radiation that it is exposed to. There is less air that the body can access. There are dietary changes due to not being able to have fresh foods due to the atmosphere. These can all affect the digestive system by shifting the ratio of bacteria. This, however, is still under research as to what exactly is causing the shift, but these are all potential reasons. Humans, to prepare their digestive system for microgravity, can maintain a healthy diet with plenty of fresh fruits and vegetables to ensure they have plenty of nutrients before entering microgravity and after returning to Earth. While in microgravity, they can exercise, try to eat the healthiest they can, given the food options that they have. They can also do their best to avoid getting sick by practicing good hygiene and by keeping their living space clean. There is currently some research being done on the effects to the digestive system from microgravity. One major experiment that has recently been done and results still being analyzed is the Scott Kelly experiment. This experiment is where an astronaut named Scott Kelly went into microgravity for nearly a year, while his identical twin brother remained on Earth. The experimenters monitored Scott Kelly's and his brother's vitals, blood, etc., constantly during, before, and after entering microgravity. They studied everything they could to get a sense for how being in microgravity long-term affects each system in the human body. Specifically for the digestive system, they studied the bacteria in his stomach and watched as the ratio of firmicutes and bacteroidetes changed. The ratio returned to normal shortly after Kelly returned to Earth. Many scientists are now trying to figure out why this shift occurred and how to fix it. There are many theories as to what could have caused the shift in the ratio, such as radiation, less sleep, less air, stress, and dietary changes, but none have been proven yet. The purpose of this research is to try and find ways to maintain a balance of bacteria in the digestive system to protect it, maintain homeostasis, and ultimately be able to travel for longer periods of time in space without having to worry about damaging it. Overall, the digestive system is not greatly affected by microgravity, and there are no foreseeable long-term effects to it. That's the end of my project.